All right, I'm back. Still on page 235. This is part C, which we just did. Part D is going to refer to part B. So ahead of time, I actually copied a few things from part B, which you might need to do. So what I've copied is I copied the parametric equations for the surface that we found, and I also copied the picture. And so in this question, what we want to do is intersect the solid that we formed in part B with the plane y equals 3, describe it as thoroughly as possible. So let's see. First, I'm going to try to draw it. So, all right, y equals 3. So I'm going to say it's like, hold your horses. I'm almost there. All right, I'm ready to go. Y equals 3. So here to like here, I suppose. And then we go straight up to here. So you can see that we're basically just getting a circular cross section, right? And we're going to be able to describe that. I think this is not going to be a problem for us. So let's do it in a plane. So we're in y equals 3, but I'm going to draw here. Oh gosh. Let me move that guy up. Okay. So a circle, and you can see it's going to be a circle, and that's good. Like so if you're going around the y-axis, then y equals something is going to give you a circle. If you're going around the x-axis, then x equals something will give you a circle. Around the z-axis, then z equals something will give you a circle. You couldn't rotate the region that we currently have around the z-axis. I mean, you could, but it's not an interesting figure. It's not a 3D figure. So we're actually in the plane y equals 3. And we're getting, so this will be x and z and 10. So we're going to get the circle x squared plus y squared, x squared plus z squared, sorry, equals 100. So let's describe it. We're going to get a circle with a radius of 10. And I guess we should say the area is 100 pi units squared. So that's like a description. Now, can we write an equation for this? We definitely can, right? So we know that y is equal to 3. We know that it's a circle in an xz plane that has a radius of 10. So I can go 10 cosine, 10 sine. But look at the parametrics that we've already written for the surface. If I just let y equal 3, what do I get? I get exactly what I was just talking about. So x, I'm just borrowing, is 10 cosine of t. Now y is equal to 3, and z is 10, sine of t. And t can go from 0 to 2 pi. Let me get rid of some straight marks again. So the parametrics that we wrote in part B are going to be super useful because I can like utilize those to figure out what's happening in anything where y equals a constant. It's going to work great. You know what I'm going to do? I'm going to go to Geogebra and add that. So I still actually have the page open from the other part that we did from part B. I mean, that's probably not so surprising because like I'm still doing the same problem. But this, so let me graph. So what do I want to graph? I think I want to graph a surface again. And I'm going to graph 10 cosine of t, comma 3, comma, whoa, look at that. 10 sine of t. I don't know what was happening there. T goes from 0 to 2 pi, but I need another parameter, so I'm just say v. It goes from like 0 to 1, something like that. And what does this look like? It looks like nothing. Why does it look like nothing? Oh, I have a thought as to why it looks like nothing. Because it's just a circle. It's not actually a surface. Let's turn it into a surface. I'm going to do something a little weird. I'm gonna go back in here. I'm gonna change my tens. This is me legitimately not knowing what is happening, by the way. I'm not doing like that rhetorical thing. All right, I'm gonna make this V. This is gonna be cool. I'm gonna make this V, and then I'm gonna let V go from 0 to 10 because the radius, to fill it in, I want the radius to start at 0 and then go all the way out to 10. I think it's gonna fill it in. Let's see. Oh yeah, look at that. There you go. That's what I was hoping for. So that's actually kind of fun to play with. You can make it, let me just make like, I don't really need to be doing this right now, but I'm going to. I'm gonna say R equals like 1 or something like this. And let's have this go from 0 to 10. And then up here, let's click and change this to R. And then let's animate it. And it's a little slow. There you go. So you can watch it like fill in the space, but it'll never go more than the cylinder because I stopped it at 10. Kind of looks weird. It's like a spider web kind of thing. All right, so I'm gonna stop that. And I'm gonna go back in to the iPad, to the notes, to whatever. It's not really relevant to you that I'm going back to the iPad, but that's where I'm going. And I think that we answered this question. So I'm gonna move on to the next part. Describe the intersection of the solid formed in part B and the plane x equals 6. All right, looking at this figure, so think about your wheel of cheese that I mentioned in like part B maybe. Instead of slicing it like with the circles, right, which is perpendicular to the axis of revolution, instead of going perpendicular, we're going to go with the axis of revolution. So the easiest thing to think about is what if we went like straight through? So basically, what if we took this and we just let the like z-axis like slice straight through there? You can actually see what we're going to get. You can see that there's a rectangle there. But remember, we're only seeing 1/4 of it, which means we're only seeing half of the result because this rectangle could also be kind of, I can't really draw this. You know what? I'm not going to draw that. I'm not going to ruin this picture yet. I'm going to ruin it with the actual problem. So x equals 6. Here I go. Let me just set this up. All right, x equals 6. I'm going to go like straight across. And then I'm going to go straight up to there and go up to there. Now you can really like see how I didn't quite master this. Actually, that is not bad. That's sort of what I was going for. But that's only half of what I wanted. So the other half of what I wanted, I think I can do this. Hold on. I'm creating like a lot of these weird little, you see these little dots on the side? Like what are those? How am I making those? I have no idea. All right, so this ideally, I would like situate right there. And then I'm gonna do the same thing here, then go across. That's the intersection that I'm gonna get because that would be the entire thing. So if you have, I don't know, if you have something that you, like if you're making cookies, right? So like you make a cookie or a biscuit or something and you just like slice through it, you can see that the cross section you get there is actually a rectangle. So we wanna figure out this rectangle. And like maybe you're looking at it and you can just see, and that's good. But if you're not, what we can do is we can start thinking like, what does it look like in the XZ plane? Like what is happening there? So in the XZ plane, so the trace of the surface in the XZ plane is a circle. So let me fill that in. It's a circle that has a radius of 10. So circle of radius 10. So this is X and this is Z. And this is 10. All right, so the equation of that, if we're doing this, is x squared plus z squared equals 100. So now I'm going to let x equal 6. I'm going to take a vertical line because in this system, x equal, well, yeah, I mean, in the normal xy, it's also a vertical line, but vertical line at x equals 6. I need to figure out, like, where does this intersect this circle? So I have two options. I can take 6 and I can plug it in, like right there, get 36, subtract it, get z squared is 64, that's 8. Or in this particular case, because it's not really bad, although I just solved it, you get like a 6, 8, 10 right triangle. But the key thing is that the intersection point right here is 6 comma 8, where that's x and z. And then down below, this intersection point is going to be 6 comma negative 8. So z can go all the way from 8 down to negative 8, or go from negative 8 up to 8. That's what's happening there. Y I know is stuck between 0 and 4, and then x is just equal to 6. So I think I'm ready to describe this thing. So this rectangle, I'm going to label it right on the rectangle. Like this distance here is 4 for sure. This distance right here is from 8. So let me like fill this in. This point is 6, 8, and then, no, it's not. It's 6. What is that? It's 6, 6. What is it? Oh, y is 0. What the heck? 6, 0. That was embarrassing. Let's not talk about that. 6, 0, 8. This point down here, there's like way down here, is the point 6, 0, negative 8. I gotta say, like going back to that, everybody gets confused once in a while. Like you can know this stuff cold, and all of a sudden you're just like, what? Where am I? And that's what just happened to me. It's like I don't even know what coordinate system I'm using anymore. All right, let me describe my intersection. So it's going to be a rectangle that has like a base, I guess, of 4 and a height of 16. And so it has an area of 64 units squared. Okay, so that's pretty good. And then I want to describe it. So let's think back to what I said. We know that x is equal to 6. That's not allowed to change. We know that y can be anything between 0 and 4. Look at the picture. You can see that. And then z is going to go from negative 8 to 8. So I'm going to write some parametrics for that. So x, y, z. Okay, so x we know is going to be equal to 6. That's like the whole idea. We said y could be anything between 0 and 4. So if it can vary, it needs its own parameter. So I'm going to say that it is t. And now, oh man, just so many stray marks there. 0 to 4, because y is stuck between 0 and 4. Look at the picture on the y-axis. And then z can change. So I'm going to make that v. And z can go from negative 8 to positive 8. So I'm going to say negative 8 v to 8. All right, so if you know me, you know that what I'm about to do is switch over to Geogebra, put this in, and then I will probably end this video. And then we'll be done with the first problem. And the first problem is like the hardest one to get through because all of this is new. You've never really thought about this before. But they're going to get a little bit faster, maybe a lot faster, depending on how much I talk. All right, we're back to Geogebra. I'm going to do surface. Surface. This one's simple, 6tv. And then t goes from 0 to 4. V goes from negative 8 to 8. Oh, look at that. It's so cool. It's so cool when you do these things and they just like work out. So we got this. And then, I mean, like, there's all these ideas that we could have where, like, could we make this so that, like, we'll let x vary. And as x varies, we would need to, like, constantly recalculate what z is doing. Y is always just going to go from 0 to 4. So it's, like, boring in this scenario. But, like, we could potentially do that. And the way you would do that is the top half of this thing is the square root of 100 minus x squared, right? That's because it's x squared plus z squared is 100. So it'd be the square root of 100 minus x squared. And then the bottom part would be negative that. So I'm going to try it. I don't know. This might work. It might not. I mean, it should work. So I'm going to let this be, so what am I going to, I'm going to let this be like t, right? So I'm going to let x vary. And if it works, you'll see it. If not, you kind of won't. I'm going to let, what am I doing here? I'm going to let this be, what am I doing? Oh, wait, let me make this k. I don't know. If you don't want to watch this, obviously, I'll see you in the next one. I'm going to make this be like t, let this be v, and then t can go from negative square root of 100 minus k squared, okay, to square root of 100 minus k squared. This is either going to work or definitely not. And then this just goes 0 to at t, y, v. Oh, I flipped them. I flipped them. Okay, hold on. This is not going to work. But I can save this. What should I do? T. This is supposed to be v, and this should be t. Ugh. And then t is the z thing, and that can do this. And v is the y thing, and it should go from here to here. There is no k, though, so I'm hoping it just makes a k for me. And it did. And now I'm going to animate that. Yes. This is exactly what I was hoping for, except it's not going far enough. Go negative 10. Negative 10 to 10? Why would I do that? Negative 10. Negative 10 to 10. I feel like it should only have to go 0 to 10. But, I don't know. Let's see. 10. It's good. Negative. Oh, the negative is because of, like, think of the figure in the XZ plane. It does go from negative 10 to 10. I was just picturing the first quadrant thing. All right. I mean, I feel pretty good about that. I'm going to stop this here. That was all kind of like, some enrichment or supplemental material. And I will be back in the next video to talk about more of this stuff. All right. See you then.